Hello everyone. So today let's solve the problem 416. Partition equal subset sum, right? So let's see what the question states here. We are given an integer array nums. You can clearly see here, right? 1, 5, 11, 1. It consists of the elements 1, 5, 11, 5, right? So given an integer array nums, we have to return true if you can partition the array into two subsets. So we have to partition the array into two subset. See, they have given the criteria. Listen to this further. So if we can partition the array into the two subsets such that the sum of the elements in both sets is equivalent or the is equal or equivalent or false otherwise, right? So see here, we have 1 5 11 5. Yeah, this can be partitioned into 1 5 5 and 11. So this leads to 11, this leads to 11, and this particular one also leads to 11. So in this case we have to go with the true, right? We have 1 2 3 5. Let's try this one with 5. 2 plus 3 becomes 5, but we have to make use of this element at any cost, right? So we have to go with such that the sum of the elements in both the subsets, we have to go with the array into we can partition the array into two subsets such that sum of the elements into both subsets, we have to consider all the elements. It doesn't matter. See here, 2 plus 3 we can go actually, but here this will be 5 and this will be 5, but we have to consider 1 as well. In this case we have to go with 2 plus 3 plus 1, right? So this will be equivalent to the 6 actually. Suppose if we consider 5 plus 1, this one 5 and 1 and 2 and 3, it will be 5 and 6. It is not equal. In this case also it will be false actually. So it is not possible here. In this case we have to return the boolean value false, right? So this is fine. The array cannot be partitioned into equal subsets basically, right? They have given us wonderful examples just for the sake of understanding, right? So now let's do one thing, man. Let's quickly discuss the this one approach, right? First thing, before considering the approach, let me tell you one thing. So we will be making use of the dynamic programming. So we will be making use of the dynamic programming to solve this particular problem, right? So this is fine, I believe. Now 1D DP basically, yeah, 1D DP, right? So yeah, let me write it over here, 1D DP. So let's start with the let's begin with the approach part. So let's consider this first example itself for the approach, right? First, what we will do, we will compute the total sum. So what is the total sum of the elements here? This one. So this one, compute the total sum. So total sum, sorry, this will be 1 plus 5 plus 11 plus 5. So it will be equivalent to 11 plus 5, 16, 16 plus 5, 21, 21 plus 1, 22, right? So this is equivalent to 22, right? So let's move on with the second step. So the next step here would be, we will be making use of the Boolean 1D DP array. Suppose let's consider DP of S here, right? So this let's go with the same this one variable name for this one as well within the code as well, right? So let's make use of the Boolean 1D DP array DP of S, meaning here uh, we are checking, can we make some S using some processed elements? Can we, that we will check, right? So initially let's set this one dp of s, whatever we have made use of. Initially let's set dp of 0 to boolean value true. For the true, I'll just write the capital T here. This one is nothing but the boolean value true. So this is the base case. Next, we have to process the numbers one by one and update the dp backwards, right? So after one this one element one, after one, reachable sums are 0 comma 1 basically, 0 comma 1. So we, in this case, we will set dp of 1 true, dp of 1 is true, right? So this is fine, I believe, easy. Now after 5, after 5, this one, after 5, the second element, after second element 5, so this comes under second this one itself. We are processing numbers one by one, so this comes under third point, right? So this is fine. After 5, after 5, reachable elements are this one, what do we call, 0 1 5 as well as the 6, 0 1 5 as well as the 6. This is reachable, right? So what we will do, we will set dp of 5 and dp of 6, this one as true. Dp of 5 and dp of 6, we will set this one as true. Let me write this one completely here. We will set in the second point after 5, we will set dp of 5 equals true, and we will set dp of 6 equals to true as well, right? So that's what we will be doing here. Simple one, right? I hope you understood this one, man. Yeah. Now next we have to consider 11. after 11, right? After 11, what are the reachable ones basically? We can just go with 0, we can just go with 1, we can just go with 5, we can just go with 6. 5 plus 1 would lead to 6, so we can just go with 6, and we can just go with the element 11 itself directly, and also we can just go with the 12 basically. 11 plus 1, we can just go with the 12. So 11 plus 5, we can just go with the 16 as well. That is also one of the this one of the digits that we can go with. 11 plus 5, right? Next, 11 plus 5 plus 1, nothing but 11 plus 6 here. In this case, we can just go with a 17 as well. So these are the reachable ones. After 11, these are the reachable ones, right? So then what we will do after this one, we will set dp of 11 to true. These are reachable, right? So we will set dp of 11 equals to true. We have already found 11, right? So we have already found 11. So in this case, what we will do, we will set this one to Boolean value true. We will set this one to Boolean value true, right? So one more thing you have to observe here, because dp of target, nothing but in at the last step we have set dp of 11 equals to true, right? So it can return true, right? So here, because dp of target becomes true, the array can be partitioned. The array can be partitioned here, right? So the output that we got here is true, which is equivalent to the output that they have mentioned for the example one within the question, right? So now, uh, as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity and the space complexity? The time complexity would lead to big of n into target man. The time complexity would lead to big of n into target, right? So why it is big of n into target here? Where target is equivalent to, so this target is equivalent to total sum by 2, total sum divided by 2, right? So this is almost equivalent to big of n into sum of numbers, right? So n into sum of numbers, this one numbers they have given, because for the each of the n items we update up to the target states, right? Accordingly with the criteria, accordingly with the this one approach that we went with. So overall we can just write it here, big of n into target, the time complexity. So what will be the space complexity here? The space complexity would lead to big of target, right? So the space complexity would lead to big of target, right? So why it is big of target here? So we went with a 1D Boolean array of size target plus 1. We went with a 1D Boolean array of size target plus 1, right? So this is fine. So the space complexity we would consider because of target, right? So the time complexity would be because I mean the time complexity and the space complexity for the code that we'll be writing in the future would be big of n into target as well as the big of target respectively, right? So now as we are completely familiar with the target, not the target one, approach and the complexities, we are good to write the code. Let's start writing the code. The first step here would be, let's compute the total sum of the array. Initially, let's set this one total to 0, right? So we have to go with the total, the this one, right? Total, because we have to sum up all the elements within the nums. So that's what we did in the approach. So whatever we discussed in the approach, right? The same thing we will be articulating in the form of code. Now let's accumulate every element into the total. So this one will be for int v of nums, right? So this one, let's set total equals total plus v. Now let's do one thing. If total is odd, we cannot split into two equal integer sums. We know this one, right? So let's go with a quick odd check using the bitwise AND. Let's make use of the bit manipulation for this. So this one will be total bitwise AND 1. If it is equal to 1 meaning odd, then it is not possible. So in that case, we will return false. Yeah. Now let's do one thing. Let's move on with the next step. So if the target sum, when we consider target, this one sum, we must be able to make with a subset, right? So we can just go in this way. Int, let me leave space here. Int target equals, so we will be going with a total by 2. So this is fine, man. The next step would be, as I've said, we'll be going with a, we'll be making use of the DP array, right? So I'll just go with a Boolean. It is of the type Boolean. We need the solution within this one, right? In the form of Boolean value, true or false. So I'll just go with new Boolean of size, basically target plus 1. Yeah, this is fine, man. Now, initially, base case, we know this. I have said you this one during the approach dp of 0. We will set this one to the Boolean value true. Now, this is fine. Let's move on with the further steps, man. After the initialization, what we have to do? Iteration. So let's iterate over every number and update the dp from high to low, right? So that's what we will be doing. So I'll just go with here int num of nums. This is fine. So within the for loop, let's do one thing. Let's only consider the sum s that is greater than or equivalent to the num. So we will be iterating backwards just to prevent using the number multiple times, right? So let's go with the reverse iteration, or yeah, let's go with the reverse iteration basically. So this will be int s equals target s greater than or equal to num, and let me decrement s. So this is fine. So if we could make s minus num before, then now we can make s by adding the current sum as well. So let's go with a simple if condition. I can just write it in this way. If dp of s minus num, then let me set the dp of s to Boolean value. This is fine. Yeah. Now let me come out of this one entirely, man. Let me come out of this one entirely. Now let's do one thing. Let's go with a optimal early exit, meaning if the target sum becomes achievable, then we have to return true immediately, right? So then we have found a subset that sums to the target. So if dp of target, so then what we will do, we will return this one true, right? So this is fine. The final one here would be if after processing all the numbers, nothing but dp of target is true, then the partition is possible, else not. So let's return dp of target. So right, so this one will be dp of target, right? So let me format the code once and let me hit the run button. I hope this works. Let's see. We have this one has to be bitwise and man. Sometimes shift doesn't work, I believe. Let me run this one again. Yeah, now the sample test cases are getting passed. So let me hit the submit button quickly. Yeah, now we can clearly see here the sample, all the test cases are getting passed. Means whatever the code that we have written works absolutely correct, right? So yeah, I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.